All right, I'm going to teach you guys how to factor with a leading coefficient greater than 1. What I mean by that is we typically have these quadratic equations where we have y equals ax squared plus bx plus c. And it's quadratic. We know it's quadratic because it's to the second power, and we have a, b, and c are these coefficients for the different variables here, for x squared, for x, and for c is the constant. When our a is greater than 1, a lot of books will teach you to just guess and check, which I am just not a fan of. So there's a method where you can use an x to determine your factors and then use that to factor out your quadratic. Let's say I have the equation or the expression, I'll just use it without the y, x squared plus 11x minus 10. Now, if I had x squared plus 11x minus 10 by itself, I would be looking to see what multiplies to negative 10 that adds to 11 if that worked out. But because we have this 6 in front, that changes things up. I'm going to start with a basic quadratic where my a is not 1. I'm going to start with a basic expression where my a is 1. Let's say I had x squared plus 5x plus 6, and I made an x. I would put a times c at the top, and I put b at the bottom. So right now we have this imaginary 1 as my a. So a is 1, b is 5, and c is 6. So a times c is 6, and b is 5. And then I think about what multiplies to 6 and what adds to 5. So what multiplies to 6 is 1 and 6 and 2 and 3. What adds to 5 would be 2 and 3. So then that factors to be x plus 2, x plus 3. And it always breaks up like that whenever you're talking about a being 1. Well, if a is not 1, in this example, 6 times x squared, or 6x squared plus 11x minus 10, we still employ that method of a times c and b. In this case, for this problem, a is 6, b is 11, and c is negative 10. So a times c is negative 60, and b is 11. So I have to think about what multiplies to 60 that adds to 11, or what actually multiplies to negative 60 that adds to 11. Before I even consider my positives and negatives, I just do a list of all of the things that multiply to 60. And then that's the list runs back. So this should be my list, but then when I'm talking about multiplying to a negative, one needs to be positive and one needs to be negative. So I can think about the different combinations of this, like positive 1 times negative 60, or negative 1 times positive 60. Those would give me negative 60, and I can do that on down the list until I find the appropriate pair that multiplies to negative 60 that adds to 14. So if I have a positive 15 and a negative 4, 15 times negative 4 is negative 60, and 15 plus negative 4 is 11. So this is my combo of numbers that I'm dealing with. What I then do is I take my quadratic that I'm dealing with, 6x squared plus 11x minus 10, and I replace this 11x term with the values I found here and here. So I take 6x squared, and then I write plus 15x minus 4x minus 10. And now I factor by grouping. When you factor by grouping, I make a split here, and I look at the first two terms and the last two terms and see whatever they have in common. This is shared a 3x here. That leaves me with 2x plus 5. Basically, I'm factoring out a GCF. And the goal is, when I'm factoring by grouping, I have to make sure that this matches whatever goes right here. So to go from negative 4x to 2x, I need to factor out a negative 2. Negative 4x divided by negative 2 is 2x, and negative 10 divided by negative 2 is 5. So I have my factored terms. I then factor again, and I write 3x minus 2 and 2x plus 5, which is my polynomial factored. I'll do one more for you. Let's say I have 3x squared minus 2x minus 5. I take my diamond, or my x here. A times c is negative 15, b is negative 2. The things that multiply to 15 are 1 and 15, and 3 and 5. To multiply to a negative 15, one has to be negative, one has to be positive. So to sum to a negative 2, I need negative 5 and positive 3. Now I'm going to replace my middle term with these two new values. So I have 3x squared minus 5x plus 3x minus 5. And I factor by grouping. So I split here. The only thing that 3x squared and 5x share is x. That leaves me with 3x minus 5. And remember, I want 3x minus 5 here, which is what I have. So all I can take out is a 1. So I have 3x minus 5 here. Regrouping again, I have x plus 1 and 3x minus 5.